le tun truma chuan electricity ti chapter atanga kan la ti lo zonga kha kan enanga a heating effect of electric current atang kan tranang. Since source of electrical energy brings about the change in the natural movement of the free electrons, the flow of electrons through the conductor causes the heating, magnetic and chemical effects along with the current. The conversion of electric energy into heat is known as heating effect of electric current or Joule's heating effect. We will now discuss the heating effect of current. Heating effect of current kan ti khan electric current kan naya chumi wanga wire khan alo sa amo bulb antenna bulb te lo connect tai la kata khan alo lumanga heat khan lo pe chok don ani chu heating effect of electric current kan ti khan ya khami thlen tu ka no alamo metal nilovin electric current ani wangin effect due to electric current te kan ti ni chuan a omjia a chan ber chu electrical energy kha free electrons awang khan lo ta free electrons kan ti chu electron cheson chekwal thei ti khan kan lo chin che phatanga flow of electrons ti chu kan thria wire mo conductor kan ti wire te hi conductor kan ti chi chu ani ta copper kan ti chi te ta chuan electrons khan nei ve ka chan chu atom in engkim asiam awang khan atom chunga electron te anoma ti chuan valency te amo kang electrons free electrons kan ti chi te mundanga cheson te awaka kang awaka an lo flow khan an lo mun ka tang mun dang kal khan electric current kan ti ka kan lo nei ta chumi wang chuan heat ka lo produce trin ani heat mai ba ga chapter next chapter kan zir tur electric current atang khan magnetic field te kan nei te magnetic effect te kan la nei dom bokani tin chemical effects te kan nei boka chemical effects kan ti h1 kha electric and non electrolysis te poka example pakhat thatak chu ani electric and kalti rawanga chemical zonga effect anei khan chuan electrical heta definition a chuan conversion of electric energy into heat is known as heating effect kan ti kha ani mai ni causes of heating effect of current achat na ka kan chui don ani when potential difference is applied across the ends of a conductor the chemical reaction within the cell generates the force to move electrons between the two terminals of the cell. Potential difference kan ti hi battery kan di ang chi kha ani a kanan connect khan an potential ka positive terminal le negative terminal potential ka loin ang talwa chumi wang chuan potential difference ka kan lo nei ta charge ka mun ka tang khan mun danga khan an cheson thei to don ani chuan khami cell kan ti chung battery chunga khan chemical reaction ka lo oma chu chemical reaction awang chuan kha electron khata electron omhawa ka terminal kan electron omhawa ka chumi umji chu battery kan nei chuan positive le negative khami more lampanga electron omhawa ka mun ka tang khan mun danga khan an kal kwal thei ti na ni chu chunga ni lo wire te kalo connect tai la ta chuan an kal tlang don ti na ni. When it is connected to a resistor or an electric gadget, the free electrons present in the conductor move towards the positive end. Chuan kha battery kha resistor kan ting chi te amo phone te polo ni ta se kan lo charge ta bulb pang chi te polo wa tai la khati kan bo che khan conductor electrons free electrons omhawa ka positive lama khan an kalani positive lam kan ti khan battery positive lampang khani conductor kan ti chu circuit ai chuan electric wire hi ani mai thin ta chuan during their movement they collide with the atoms chutia free electrons so akha positive lama ankal ta chiam khan atom kha conductor wire atom lo omve khata ions begin positive ions kan ting chi khami te nen kan lo insuta chuan of the metal arranged in lattice thereby increasing the kinetic energy of vibration of the atoms. Bazar lun laya mo bazara mi to de laya vatlan vatlan tum dan ang vel ani mi tot takara chon lo tlan tai la mi kan su mi tam tak kha kan su dona chuting chi chon heng free electrons te po kha metal ions atoms lo chi te khang ho ne kan lo in su ta chumi wang chon kinetic energy or vibration of atoms kha lo mani kinetic energy kan ti chu thil a chet na wanga energy kan nei kha ni ta a te chuan vibration kan ti chu kan rianga vibrate kan ti chuan ang hing angor kan ti phone a te pun vibrate mode da te ang chi hi tiang kha alo thlen ta ni chumi wang chuan vibration lo wang kan kinetic energy wang kan kha vibration a khan heat kha lo produce ta a kan kut te po kan no chuan alo lum da thina chuting chi chuan atom le free electrons kha atom kha conductor atom te le battery a free electrons so kha anan in suta a chumi wang chuan heat kha lo produce tina ni. As a result of this, the heat is generated which leads to the increase in temperature of atoms of the conductor, and thus resistor gets heated up due to flow of electric current through it. This is how electric energy is converted into energy. Achan bera chu kami an su da wang kan vibration ka lo ta ka vibration ka kami kan heat ka produce ti nani. Chuan heat produced by electric current. Consider conductor of resistor R, let I be the current flowing through it, and V be the potential difference across its ends, and T the time during which a charge Q flows through R in time T is given by Q is equal to IT. Chuan example kan nei nga ta chun circuit kan nei a chuta chuan resistor kan connect ka chuan battery kan nei boka potential difference chu V ani chuan heta Q is equal to IT kan ti kha current formula tanga kan siam chu tawani current chu charge per unit time kan ti kha ni ti ka le na ma son pe wang kan a charge ka Q ani chuan flow of charge tura kan a charge flow tur za da kha Q lo ni ta se current tan I capital I lo mang tai la resistance of a resistor tan kan R mang tai ila kan ti ta potential tan V ti chuan akal hun chung ka T. We also know that the work done in moving 1 coulomb of charge through a potential difference of 1 volt is equal to 1 joule. Hence, work done or energy produced by the source in time t or energy supplied by the circuit to the source in time t will be this one heta energy ka amo energy ka energy lo in cm to za da chu work done ne kan include atia chu work done chu in terms of potential le charge angin kan da te chu v into q ani chumi chu potential chu w by q tia kan ti trina ka direct ka kan sia chuan w zonga kan sia chuan v into q ania chu ta work done ka energy produced and kan in anawangin E is equal to VQT kani chuan he energy hi heat angin lo ta heat ang kan apecho energy a hian chi rang rang kan chemical energy ti te electrical energy mechanical energy kan ting chi te tuna ta hian heat energy informed in the form of heat ani wagin H in kan data chu H chu W nen lo into kan ti leta work done nen kan chuan H is equal to VIT ni na chana chu Q aka charge aka I into T ni wang ani te chuan kan chokla zel ta V ka ohms law tang kan IR ani wangin IR kan data te chuan I square I pan hi kan lo nei ta R le T nen chuan kha equation aka hi da producer da ka ni te chuan I is I square le RT current square le resistance le a time period kan nei chuan a heat a producer tura kha kan tra thai don ani chuding je chuan a heat kha in terms of potential ang zong pun ka da te ya potential ang zong ka da don chuan VIT equation 1 VIT laya aya khan ohms law ka kan mang ke wanga I is equal to V by R T laya kha this one V square by R into T ni hi da kha in terms of potential amo current in kan zong tai resistance le then time impact chu one ti na ni chu heat kan zon chwa tai dana equation chu ni Joule's law of heating effect. Joule in 1941 studied experimental the heating effect of current and stated that when current flows through a conductor R, the amount of heat produced in the conductor is directly proportional to the square of current flowing through the conductor in a given time, that is H directly proportional to I square, resistance of the conductor, H directly proportional to R, time for which the current is passed, H directly proportional to T, H is directly proportional to I square RT. Joule khan kumsang kha zakwa somli pakhat khan experiment allows naya allow beya chuta chuan heating effect of current kha allow muchok ta chuan kha proportionality mang khana represent ta chmium ji chu current kan ti san current na kha I square kan ti san pau le hi ta kha sang bezel tam bezel tinani ta ti chuan hi ta kha resistance a ingat boka resistance san le a hi ta kha produce kha sang le bok ti ani a ti chuan a hun chung kha time period a kha rei tak current kan kalte chuan a hi produce a poka atam do na ni rei lo te kaltir ei nen kan te kin taila chuan chu a mu chuan ni a ti chuan khami a proportionality jong jong pathuma la khom kan heat kha I square R le T a kan ingata an san I value te R value te T value te lo san kan a heat producer poka sang ti nani. Practical applications of heating effect of electric current. When electric current flows through a resistance wire, the wire gets heated up and the electrical energy is converted into light as well as heat. The heating effect of electric current may also be used in different ways. Let us now discuss a few examples. Practical application at chuan current akal khan heat producer chu mai baga light produce del bokani chu electric bulb atang khan kan soi fia ang. It consists of a metal filament of fine cold tungsten wire enclosed in a glass bulb with some inner gas at suitable pressure. So one bulb kan ne bulb incandescent lamp or bulb kan ti hey R in velan man chi nang chi 60 watt ting chi te 100 watt kan ting chi te ka achunga khan gas inner gas kan ting chi gas kha anda ta khami chunga omdai tur bi ka ti chuan heta a filament kan ti a mor te achunga a eng ron eng beraka tungsten element kan ti tungsten ina siamani koilangin kan siama a kirbe bang khan chuan kha current kan hang kalte che khan when current passes through the tungsten wire which has a high resistance ti omji chu current tam tak kha lo resist tinani current chak tak poka sang tak poka lo resist tinani. The temperature of the filament increases to 2000 degrees Celsius ta hian aron ti chianga temperature kha satak po lo ni ta se 2000 degrees Celsius vel po lo ni ta se ama kha ache mei lo ni akiak mei lo ni dena me sung te chu 100 degrees Celsius vel po current local ti taila kan chevek tai dona maro chu filament tungsten being akachuan sang degrees Celsius sang ni vel po ni se intin ma omlo ama ka chelo tinani chu maro chu ama ka ron sat til ta aron eng ta ka kan electric bulb lo endan akani due to this it becomes white hot endan apoka it's white hot and starts emitting light. Tungsten metal is used as a filament in electric bulb due to the following reasons. Ngatingi tungsten hi kan man ker copper te ngatingi kan man lo copper chuan a eng ma kan ama ka atlek dei don ani mo I metal dang te chu lo ni ta se. Number 1 it has high resistivity sang taka resistivity nani 5.20 into 10 to the power 8 0 per rate 1 is nga 0 per rate is nga chumi nen chun 5 multiply ta la mo noi chuang resistance chumi zat vel chu alo resist tai tinani. It has high melting point kan ti chuan atuiral harbi tina sangthum zathum somre degree Celsius vela chau kana tuiral don tinani. It can be drawn into very fine wires chuan wire te tak te sin te kan siam te poka. It is not brittle at high temperature lo sang ma se atliak ve me lo ni chung te wang chuan tungsten aka atangka em mani. Next hian Fuse wire. Fuse is used as a safety device which works on Joule's heating effect. It is a wire of short length, often pure metal like aluminum, copper, iron, chuan PB ka antimony ka kaching to PB or alloy of copper and tin or lead and tin. When the current passing through the gadget exceeds the limiting value, the fuse wire metals, thereby breaking the circuit and protecting the device or circuits from getting damaged. Fuse wire kan ti chu ina hen kan dei trin ta ai fuse tan khan a wire big man kan dei ni omje ta ka chu current tam tak amo current sang tak ka local thut ta se antenna phone te lo charge amo TV te kan lo en amo stabilizer te kan man lo pe chung ka khami current sang thut amo sang tak khan kan khol te ka ti che do ni chumi ve nan chuan he ta in pon aten kan mang trin ta in chunga an lu ma amo meter box atanga lo lu ma te amo an lu nuwa te pon ta khan fuse wire ka kan mang ta chu fuse wire chu electrical component rang rang kan mutheya intinan guitar battery namo music lampang ti thin nom chuan amplifier nga chi te po hian in muanga ta chuan ti bera chu current sang tak local khan ama ka achat thei tur khan an siam ani ama ka lo in sacrifice ti na ni omje ta ka chuan sang tak local khan ama ka achat chia khan current ka sang tak ka in chung kan lut talwa kan khol kan electrical appliance wa kha aveng him ti na ni current sang tak la kan tanga chetur laka ka min veng him aven him sak ti na ni chu the thickness of the fuse wire depends on the maximum value of the current through the circuit. The fuse used for domestic purposes are rated as 1A, 2A, 3A, 5A, 10A, 20A. Hi chu an man dana le an label dana khani kan man dan tura zir khan a fuse apoka sin te an ni te ya sin lu tuk lo te po ni te tin ani kan mo dana zir khan. Electric power. When electric current flows through an electric device, some of the electric energy is used in doing useful work. It is always desirable to know the rate at which the device consumes the electric energy. Power of a device is the rate at which it consumes electric energy per second. Mathematical derivation kan nei le ta power kan ti chu abigin electric power kan ti chu ati thil ti thei za ta ka ti meila kan rati mang. If the potential difference across the device V and current flowing through it is I, then the work done per second by the electric current flowing through a conductor is called electric power of the device. Equation kan nga electric power chu work done by time chu mi je chu kha electrical energy consumed by time taken ti ni a electric kan lo nei ta current kan nei ta chu current awang chuan electrical energy kan nei ni chuan kha electrical energy kan nei re chuan kha energy kha engamani ti nan kan mang te ya endinan choi ya energy lo nei ta energy nei chuan nai tok te ya in khel te ya thil tam tak ti te ni le kha te zir te chu tin chi chuan izir hun chunga ro chu zir te hun chung kha omani endinan kar kha da ve kha chu choi ta la na tok don ta se ni thum ver kan dai chung kan dai tok ang tiang per chu ani ta chu tin chi chuan electric power a khan power a po kha atai mai ngata te chuan work done mo electrical energy khan en ngada ni te chuan equation a tran kan nei chu P is equal to W by T ti ni a chuan expression dang deuh lein express ka kan tum ta P is equal to W ka chu ma kan ti thong khan VIT nen khan atluk ti kan ria a mo VQ atluka amaro chu Q ka IT atluka wangin VIT ni potential into current into time tinani chuan noi le chung le noi time ka in cancel thaya VI chuan kha potential power electric power is equal to potential into current expression pakhat kan nei adang le chuan kha ohms law V is equal to IR te kan man le khan power chu I square R lo chuak don ni khalai ka chu simple method nia cancel ti vel le replace substitute ti vel mai ka nia chuan khalai ka chuan har sana homlo turangai la chuan next a ohms law kan ne V is equal to IR kan I kan ne equals to V by R kan ne khami kha kan man le che kan P is equal to V by R T by T ni and cancel le V square by R le power chu I square R le V square by R kan dei in terms of current in kan express don chuan power chu I square into R ani a in terms of potential kan express don chuan power is equal to V square by R ani hence power is equal to VI is equal to I square R amo V square by R khami khan expression pathum kan ne VI namo I square R amo V square R kan mo dana zir khan pathum mangkan kan chok tai tinani a khoi emoni ber mangkan kan chok tai tinani le SI unit poimo le tam SI unit chu system international kan ti kha ania unit kha khovel pum puina kan man tlang lon ber tura kan unit kha kan enanga power tan chuan watt manani watt chu 1 volt into 1 ampere kha 1 watt kan ti chuni entinga kan ti hian riat tura chu 1 kha anda ni mai 1 anda kan usoi ol sama chuan 1 watt equals to 1 volt into 1 ampere ani next here power of a device is device rare a power thil ti thei za da kha chu 1 watt kan ti mai ta if it consume 1 joule per 1 second 1 joule per second ani chon 1 watt ti nani power of a device kan since watt is very small unit bigger units of power used in actual practices are watt kha 1 joule by 1 second ti kha atlem em awangin kan man tak huna ka chuan kilowatt kan ti te hi power and electric department vela tang kan china 1 kilowatt 1 megawatt chanchin tara te bangan 1 horsepower kan ting chi te akat luk puini 1 kilowatt a chuan 10 to the power 3 watt ania megawatt a chuan 10 to the power 6 watt ani mega ni chuan 10 to the power 6 ania kilo ni chuan 10 to the power 3 ni train horsepower a chuan 746 watt ani horsepower chu motor a hian soi ni train motor mo engine lampang a hian power rating in India domestic voltage supplied is 220 volts India chuan in chunga kan man tura ina kan man tura ka potential mo of voltage kan te ka 220 volt ani turani charger te pon inject train he European chuan adang le deu rek teng chi khan and all the appliances work on this but different devices have different electrical powers which is marked on them this marking of power and voltage is an electrical gadget gives the power voltage rating of the gadget kha voltage rating kan ti ka chuan device khan lo siam ta kha device khan exam ya mamawang ti la ka kami en nan khan an bei mani ya khan lo inject train ta the marking 60 watt 220 volts on the bulb means the bulb will operate at the potential difference of 220 volts and will consume power at 60 watts. Bulb kan lo lei ta chuan 60 watt is ya kan muwa 220 volt ti nen kan mu kop chuan potential aman za tur chu 220 volt ni a ti chuan a watt a power zone chuan 60 watt ani akon kami za da kha mangdon ti riat tur ani ta chumi omje chu kan battery emo kan electric kan nei kha current kan nei kha 220 volts atlin lo chuan adim don amon lo pona eng thei lo wanga chuting chi chuan kan potential kha 4000 amo 400 te lo ni ta se kan bulb te kha ke phok thei don ani amamo ai tam te lo mu ta khan so 60 joules of energy is consumed by the bulb in 1 second when potential difference of 220 volts is applied across its he 60 joules kan mu chona chana chu power formula tang khan ani chuan is applied if the supplied voltage fluctuates to a value higher than 220 volt then the power consumption P is equal to VI increases and can damage the electrical appliance in china kan soi to kamo kha voltage kan potential kan pe ka asan view chuan kan electric kan bulb te mo kan electric device kha ache te ni phone te bolo che te tinani chuan phone te kan charge ma khan a compatibility ka kan treat anga power dissipation due to current when electric current flows through an electric gadget some of electrical energy is utilized doing some useful work and part of the energy is spent in raising the temperature of the coil for example electric fan is designed to convert electrical energy into mechanical energy but it also produces unwanted heat energy due to which the electric coil of the fan gets heated up if it is used continuously for a long time power dissipation at chuan kan man entinan example kan man pe thil kan charge samo and then phone the polo charge taila rate kan charge chuan allow heat allow produce in the heat ka kan mo em kan mo lova amaro chu khami akai noya ka heat effects akalo bezel ta then example danga chuan fan kan data fan a chuan thil ti tu ber chu mechanical energy ron produce tur nei chu miom ji chu aron ver tur ani ti na ni amar chu a ver khan heat kha lo produce tel ti na ni ka unwanted heat energy kan ti ka chuan sometimes the increasing kan du lo kha lo tel khan ka dissipation kan ti chu ni mai. Sometimes the increase in temperature due to flow of current alters the properties of the conductor, and this may vary the result. For example, on passing current through a nichrome wire for a long time may affect the readings in Ohm's law experiment. And in Ohm's law experiment, you can see V is equal to IR T lo chuak na kanita V is directly proportional to I kan ti ka current san chuan potential sang vessel kan ti na khani mar chu khata khan khamite nan khan war chirang rang kat bang te ya nichrome 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 anti ka rachel wa khami wire ha lo mang tai la rei ta kan current kan kal ti khan a reading ka ati danglam vek tai ti nani ama property khan lo danglam vessel tai ta chuwang chuan kha power electrical power energy kha athadro rol khan mamo lo le changkai lo kha aron produce tel thin nei ka power distribution due to current kan ena chuni electrical energy the work done energy liberated or consumed by electrical appliance during its operation is called electrical energy chu electrical changa energy kan nei tila awesome bero me. From the definition of electric power kami definition na changkan power chu work done by time ania so kha work done ka chu electrical energy ni energy angkan energy store nan kan inang reng ta ka energy ka electric in the form of electrical electrical energy by time kan ti chuni chuan kha kan current kha kan consume mo kan liberate ani thei kan man tura kha ani theya kan pek chua kha ani thei bok tinani chuan to beratan hian electrical energy consumed or liberated kha tuna chun kha khata electrical energy kha equation kan song to don ta chu power into time ani har lova chu power chu electrical energy mo work done by time kan ti atanga lo chuak ani hi anoi time kan ti khale lama pheya chu jong chu ni ta electrical energy chu power into time ani SI unit of energy is joule energy SI unit da chuan joule kan ti joule chu watt into second atluk tinani bigger units are electric energy kha kan mo ne mo tam tak alo in khol khan tam tak angji industrial kan man te turang chi domestic te poloni ta se kata kan man turanga chi chuan watt into second ti ringot kha atok tol watt te thamlu tu ka chuan watt into hour te kan manga chumium ji chu energy consumed when 1 watt of power is used for 1 hour daga khachung watt khat kan man kan chu watt hour kan ti chun mai kilowatt hour ni chuan daga khachunga kilowatt kan man zat ti nan mai chun hei commercial unit and tia commercial unit ti omje chu eta tu na kan man chin mo business ta na man thai antral chua electric antral chuang chi te kan leng chi te ta hian kilowatt hour in kan mang thin ani 1 kilowatt hour chun exang et luk kan ti chuan the electrical energy consumed by appliance of power 1 kilowatt in 1 hour. The electricity meter in our homes measure the amount of electrical energy consumed in kWh called 1 unit. 1 kilowatt hour ka 1 unit in the chu ina eta electric bill and share nan kan mang trina relation between commercial unit and SI unit of energy. Commercial unit le SI unit ka shan oma SI unit commercial unit a chuan 1 kilowatt manania 1 unit kan ti kha chu 1 kilowatt chuan exang it lu kan ti chuan kilo ni chuan 1000 nia watt ni chuan kilowatt ni chuan 1000 watt ti rani chuan hour ka second na SI ka chuan SI unit ka chuan watt into second ni wangin kilowatt ka watt ka thla nga ya 1 second ka 1 hour ka second ka thla nga ni sang ka into 3600 seconds nia chuan multiply ya 3.0 angin da achan chu 10 to the power something in da du ta so 10 to the power 6 kan ya watt second 3.6 into 10 to the power 6 joule chu 3.6 into 10 to the power 6 kami 6 joules ka 1 kilowatt at lukpui tinan mai 1 kilowatt hi sumdon nang ji aten an manga sumdon na ka ti khana electric impact chuan tralang chi te amo man joy kan man te eng chia khan kilowatt ang zong an ti ta maro chu scientist lo ni a thil zir zia na nai man du chuan academic paper anga zia du chuan 3.6 into 10 to the power 6 joule ang bo watt into second ang chi kha watt second ang chi kha man tur ani ti khan hemi chin hi kan du to kang apoi mo bera chu a heta kan se bera chu electric current awang kan hi da om te ti na bera ka ani mai chuan equation ne le power ang chi te energy ang chi te electrical energy te power of electric current kan ting chi te kha ho hi produce kami de pathuma kha equation a cho thei tur khan equation kha kan ne ya chu te kan chung te chu kan se ya kan en hawa kha kan zir bera